No. And this thing is not working. Okay, so seems like we're back. You know, this it's always something happens at the beginning. Well, I decided to break this exercise 5.13 into a live session for each one of these because otherwise probably it will take me the entire day. I was very insecure of tackling this problem live. I don't know why, because if we are not able to solve it, nothing happens. But still, besides, I can do it offline and think like the entire day. But still, I wanted to increase the level of pressure, or yeah, by adding some nervous to the problem. So yeah, map, take the web with zip all. This material will be 4 videos, live sessions. Let's start with map. They want us to use Unfold to implement map. Why I was insecure about this, because Unfold is recursive definition, but still it seems like counterintuitive, because we are very familiarized writing map with structural recursion or tail recursion, or mostly structural recursion and fold right. That's the reason I brought uh, my work. So so we can draw it over here. Mm, Also, this is the URL is available for you if you want to have this code as a starting point. And yeah, it's a lot of functions so far. And hopefully you are able to hear me. I'm procrastinating by saying all this. Yeah, let's get started. So simple as that. The book says use on fault to implement math. Okay. So, oh, here it is. Here's map. It uses fault right, and so fault right should be here. I was thinking to take a look at map. Uh, I didn't remember we already got map, half map under our belts. Just remember it was another exercise using fault right. So fault right should be over here. Here this, and this is this is the structural recursion we were talking about. We have uh, f applied to the head if it is a list containing elements. If there is any list, we return the empty list, and then t evaluated to fall right. So I don't know how this will resolve. Let's hope for the best. Where is map again? Yeah, we passed an empty list. Let's be clear about. I know you know this by heart, but if you have a list which you apply a function times 3, this will result on. It will grab any, it will apply this function to each of the elements of the list. 6, 9, and 12. And that's all. That's what maps do. We all know this. Now let's suppose we have a list. Why do we want to use a fold for map? Maybe you want an infinite list, but I mean, we already have a form to use map with infinite list, so perhaps with some exercise, some okay, we have unfold. Let's see what. Let's revisit, refresh what unfold does. My God, time flies. 7 minutes already. Already 7 minutes. So where's unfold? Okay, fold right. Well, let's be systematic. Let's write the type signature. We're going to write it over here. Unfold is in the companion object. No, let us, yes. All right, this is kind of, you have to practice before perhaps doing like 50 exercises with unfold before throwing yourself at these live sessions. Uh, but we have just reading the book and they are solving the problems as they are presented. Let's def map using unfold, and the definition of map is that you need to have a list to apply to have a map. Well, you can have another data structure like trees. What we are talking about, lazy list. You don't need a list to use map. There is another. There are ways to define map for other data structures. Didn't meant to say that, but in this context, you need a lazy list. No, I'm talking out loud because I want to also simulate that I am in a job interview. uh, because sometimes I get nervous. Yes, we need a list, a lazy list, which is uh, here. We will be using this. Now this is like counterintuitive because we are not, we are calling Paul right. And Paul right is taking care of the recursion with this match. So we have our lazy list. We need a state variable because we will have transformed elements. We need a function from A to B for each element of type A in my lazy list, and we need to return my lazy list. This is very important. Let me see if we are online. Yes, because we were there. Yes, yes. Now using unfold. Yes, we need to use unfold. Let's see what unfold does or what unfold do. I have my English book over here, grammar book. Uh, unfold take a state and a function is from base from this from this state to option S. Okay, and returns my list. Hey, this will be a little bit late. It applies a function to this state. So it's match is now t is some value to prime value equals to prime of and we have some examples. Oh my god, 15 minutes. Let's understand. I'm studying this code to have an even more clear idea of this unfold. From 4 gives you my lazy list, a lazy list, but it, it generates the list. So for continuing for from, you see if we find a pattern over here. From comes in and some sort of tail, maybe wheel. Continually comes a some sort of tail. And from here, where is map? Okay, so imagine if we dare to tackle the entire set of functions of these little functions, that would take us the entire day, as you are seeing, as you are witnessing. Well, why the time happens so fast? Okay, so we will have this. I will start with this function. Not usual fault. Okay, we are given a function, and we have a list. To, you about this. Let's start by calling on faults. We need a state, and we need a function. We will need at least leave b at the end. How you can think in terms of fault? If we pass an empty list, what should happen? What is this state? Are you able to see me? Yes. What's this state? We plug into the energy. Yes, 100%. If it's none, we return empty. So perhaps the state is the least? Oh, yes, a function. We have a function from f of a to b. Now we have function to the state. Uh, Let's is empty. We are returning empty already. We should return none because the function that involve that unfold expects where is it? Is some for some option. Some f. Now we have f. Now we have lots of parentheses. Perhaps you don't like this. Perhaps we will have a problem with this. Let's evaluate it. Okay, at least I was reading and programming in a Scala that um, you were that you should be able to. I will have to read again that book. We should be able to see these functions. Okay. So now we will need the list, can we see this over here? Now we are having a different problem. There is no list of us. Can we can we move and pull over up there? We won't be able to see this. And now that we are here, oh my God, we have several problems now. 27 minutes. Okay, this is true. What else? Another. So we are able to see this is not complaining about. Uh, it is not complaining about this keyword. Okay. Yes. No type arguments for playground fault. And yes. Yes, there's something. Uh, yes. Yes. You see it now. Right here it is H and T. Okay. And now we are fighting another set of issues. Perhaps I will move Unfold over there, up there. We can Yes, let's move this just for the time being, because the exercise on unfold requires you to have this AS. Let's move it for the time being, and then we can take care of the type variables. For other for prime, there's no what? I remember reading about this. They should be able to see. And now we will have the problem of empty of nothing. Yeah. Oh my God, this was like yes. Now we have covariant type A, crossing control type S. I think I will take note of these errors and its solutions because we already saw this in some previous chapters. Variant type A. Perhaps that's why the function was defined. Yes. When we look for this error, but the exercise says we shouldn't change this because this is the exercise. This is a type signature provided in the exercise. Um, this is not good. But we will take a look at that error later for whatever we have. Now we lost or we got lost map using a fault. How can we get rid of this? Okay. We have several issues about here. We have this. This is the solution of this problem. Okay, first, before going continue, I want to see we are able to see those leaders. Like we are able to see this in the companion object. Let's see. Okay, launch page empty. We don't have any. My relation is object. Let's, let's use this because I just want to see if my stuff is. I still say empty of map. What's going on with this? There's something really wrong. Okay. For this, yes, all the time. 40 minutes. We're almost there. We're just fighting with the types. There's something wrong today. Okay, we have. Okay, I'm starting to see, but the map is not like. I think we are going to receive the list in the map function because, for example, in this empty, if we want to return, we can experiment returning. Let's change it just quickly. For this is now. Now, I am probably like extremely nervous right now because I am doing lots of silly stuff. Now this is nonsense. Now that I'm thinking about it, let's still here's right now. Yes. Yes. The let's see what's going on here. Can we see this in here? Let's remove this and make a silly change, yet another silly change. We have, oh, I'm hungry. I will need to take a look at programming in Scala by Martin. Like, certainly, you can see the functions in the companion object. Okay, we don't we shouldn't move this on pole to the non because this is the exercise type signature. But map doesn't have uh, a type signature over here, so maybe we can receive the list as a parameter, but in this zip out, they are only receiving uh, that lazy list B. So perhaps they belong to the unknown definition, to the data type definition. What can we do here? Because zip all it, it only receives this that list. So we will try with receiving the list. We have some fault over here. What happens if we receive the lead? There's map using import list. Um, we receive this function and perhaps we need like this version and we will return let's list type B unfold list list case. Let's try with this. Oh, wow. Okay. Okay, we got it. But I'm not sure if this type signature it's okay. If the author is okay with this Okay, it's running. Somehow this thing got screwed. We will wait. Somehow this somehow okay. So we got our answer, but that I'm not sure if the guy, the author's intention. Now this we enter tinkering, and I don't like a lot to tinker in this setup of designing functions. Should be some, I don't know, more like knowing, because tinkering is related to trial and error, which is not nothing wrong with that. Mathematics for the millions says that the life of ordinary people is all about trial and error and struggle. And the definition of this series is that you see me struggle, join me, join me while I struggle. So it's the definition. Join me while I struggle to solve functional programming. And we did struggle today. And I'm not sure if math, I mean, we solved the exercise because, you're saying this is inside the companion object, and it is received in the list. I'm not sure about if the author's intention was to have this type signature, or if instead they want to have to be here. I will homework for me is to read again the section on it was certainly that you can see from the data type, you can see the functions in the object companion, in the companion object for a given data type. I was certainly about that, but you saw that that wasn't the case. So that's a homework for me. And also homework for me, we saw an interesting error when we were over here. So it's stating that A is in a contravariant position of F. That's interesting. Uh, I would like to decipher that error and come up with non with an explanation that doesn't include those words. Like when you're talking about contravariant data types, at least in Java, it turns out that they just need to be like subtypes or the type itself for a given method. Talking about Java, I need to continue some refreshing. And I think this contravariant position and all these technical terms will end being something like that. And I will try to see what is it about, try to oversimplify, maybe wrongly. What we did, I am satisfied with our solution. I was doubtful to tackle this function, this problem, to be honest. And at some point in the middle of solving this problem, I was like, oh my God, will we, will be able, will we, will we be able to solve this problem at all? It's here, but I'm not sure if this definition is cool because they're receiving the list. If we see the answers, then we will, if we see the answer for map, We will discover the pattern. These things will become, perhaps they will lose uh, the challenge they represent. So I will leave it that way and tackle this tomorrow, hopefully. And only after that we can see if the author. At the end, we are here to learn. So only when we finish this chapter, we will take a look, and if the author solves it in, by putting it. But again, I have homework to do because if I discover it by reading the Martin others book that in fact you can see the functions over here, then we will be able to pass this function over here. So maybe we we won't see the answer, but if we discover in the book some way that you can see the functions, I will pass this function up here and record a video on that exercise. For now, I am saying goodbye to you. I didn't think that this will take me the entire hour, to be honest. But a lot of things happened. We were at some point fighting with types, I guess. So for me, that's all. Thank you very much. I need to move to other topics, perhaps Java or SQL, and let's offer tomorrow at the end of the day with the next function, because these are like they invite you to think. It's different thinking. Like, for example, in the video game that we are implementing, it's different problems, different mindset. In the video game, we are able to think here all that what is needed. And here too, no problem with that. 59 minutes. Thank you very much. See you later or tomorrow. Thank you. Bye. We did.